Thank you very much for the introduction, and hello to everyone joining us today. I hope you all are doing well and you're safe. Great thanks to the great team for organizing the stay-at-home webinar and the opportunity to share some information about color measurement with you. Maybe a little quick introduction about TECHKON, who doesn't know about the company. So we are on the market since 35 years right now, and our focus is developing and manufacturing innovative and high-quality measuring instruments for the printing industry. I am 25 years now with the company, and I still enjoy to work here, and I support the printing industry. I have prepared some slides with information about the different standards and what you should take care when using a spectrophotometer. And after the presentation, we will go to a live demo showing how easy it is today to do quality control of a print within a few seconds. So we have heard about the different global standards and calibration methods from Neil. And here's an overview again about what is available on the market today. We have national standards, global standards, different methods, PSO, ID lines, Gracol, SWAP. For the ICC profiling, we have the ECI, we have the ICC. So there is a lot of information, and sometimes it surely is difficult for the user to get an overview. And sometimes maybe users are a little bit overwhelmed with all that information. So our task is it to make it as easy as possible for the users to do quality control, no matter what it is, if it's ISO, PSO, ID lines, or FOCRA. So we have tried to implement all these references and target values and tolerances into our products to make it as simple as possible for the users. If we have a look on the history of the standards, we see that there was a big change in 2013. So the ISO or PSO standards, also the FOCRA characterization tables, they have changed in 2013 to the new versions. Even so, there are a lot of customers and companies are still working in accordance to the old standards. So for us, it's also important to support both versions, the older ones as well as the new ones. The big difference between the standards is the measuring conditions. In the past, we have measured LAB values with M0 condition, and today the current standards have reference and target values described with M1 measuring condition. Having a closer look on the measuring conditions, which are described in the ISO 13655, it was also for us a challenge because we had to completely develop new type of spectrophotometers. In the past, these kind of color measuring instruments have used gas-filled tungsten lamps. That was not possible to fulfill the requirements of the ISO standard. So we had to use a combination of LED technology to create a certain illumination. In the ISO, we have 4 different measuring conditions. And these measuring conditions are named with M0. That is the legacy method. There was no filter integrated. It was a lower amount of UV light. And all instruments where you cannot choose an M condition, measuring conditions, it is automatically that they measure M0 only. In the latest development, we have integrated also M1, which means the illuminant D50 has an increased amount of UV light. And it is simulating the daylight. In M2, we have a so-called UV cut filter. There is no UV light. And M3 is described for measurements with polarization filter, mostly for densitometric readings. So the advantage of measuring condition M1 is that it is improving the judgment of substrates with optical brightness. So that means the measurement results are comparable what we see with our eyes. That means the visible appearance. In our instruments, we could define that in a way that we have, first of all, we have to simulate the old standard as well. So we control the amount of UV light of the UV LED to simulate the M0 condition. If we have to fulfill the requirements of the M1, we are increasing the UV amount of light. And for the M2, we just turn the UV light off. That means we have no UV light. It's the same like UV cut. In the past, you had to use UV cut filters. Today, we just change the light by a press of a button. And finally, we have the M3 condition where we have a polarization filter. We switch that filters into the lamp channel and the color sensor channel to also fulfill these requirements. The advantage of the polarization filter is it is reducing the differences in density between wet and dry inks. So it makes sense to have this option here as well. If you have a look at the history of instruments, then it's quite easy to recognize if an instrument is able to measure M0 and M1. If you, it doesn't, it doesn't, it isn't valid to our instruments only, but other instruments on the market as well. As soon as your instrument has a color display, then you mostly can be sure that it can measure M0, because older instruments, they mostly had grayscale display. So they could measure M0 and M3 only. And since 2013, there have been a lot of instruments on the market that can measure all measuring conditions, and latest at 2016, it is a standard that the instrument provide all measuring conditions in the new type of spectrophotometers. So beside the M conditions, there are also additional settings which you should take care about. For the densitometry readings, these are the density filters. So for Europe, we have a status E filter set, and we are using polarization filter for densitometric readings usually, and the white reference is paper. In the US and other parts of the world, we have a status T filter set. The polarization filter normally is turned off, and the white reference is an absolute white standard. For the colorimetric readings, it's more international. So we have the 50 illuminant, observer angle 2 degrees, and the M condition should be M0 or M1, depending on the standard you are using. And the instrument is always calibrated on an absolute white standard. So if you exchange information like LAB values or densities, it's also important to provide the settings of the device. Because sometimes we get requests from customers and they're complaining, there are differences in the values, no matter if it's density or LAB. And our first question always is, did you check the settings? Did you check the calibration? And in 95% of the cases, that is the reason for the differences. And it can be easily fixed by just checking that different instruments are using the same settings. The next important point before you start with the measurements, it is clear that you have to calibrate the device. So when calibrating an instrument, we differ between internal and external calibration. Internal is that what a user can do. So if you make a density measurement, you can calibrate the instrument paper-wide. If you do a LAB reading, you have to calibrate the instrument on the white standard. The external calibration is what is recommended by the supplier or the manufacturer of the device. That should be done every 2 years, like with your car. You go to the garage and you check your car, everything is fine and it's working. We do the same with the Spectro. So every 2 years, it should be checked that it's working properly and accurate. And this is a full calibration of optics and the spectral sensor. Once this is done, we can go to the practical part, means we can do our measurements. And I would like to show you now some practical use of a spectrophotometer, how to check the target values of ISO, PSO, and G7. And here's an overview of what shall be measured with ISO or PSO. So for ISO, we are looking for the TVIs. We want to check the mid-tone spread, the delta L, A, and B for paper, the delta E for the CMYK solids, and we also can double check the trapping patches, the overprints. If we have a look on the On the G7 task, then it's a little bit different because here we have the focus on the gray balance, as we have heard in the presentation before. So we measure and check delta E for paper. We also check the primary and the secondary colors, which are very close to the ISO standard as well. So this is very similar, but beside that, we are looking for the weighted delta L and C for the gray and the black patches. So we put our focus on all these gray balance patches to analyze if this is in accordance to the G7 target values. If you have any questions now or later, please send them to the team or to me directly later on again. I'm happy to answer any questions you might have. And even after the presentation and the webinar, you are welcome to contact me. You can find my contact details here. So we are happy to support you with uh, consultants in measuring, color measurement, but also a little bit about ISO or G7. Myself, I'm a G7 expert also, and I maybe can provide you some helpful tips in your daily work. So now I need to share my software with you. Now you should be able to see the software I'm using to demonstrating the instrument. That means you can see the results on the display. I also have an option to show you how I'm working with the camera. So you should be able now to see the instrument. And you see as well, it's very sunny. Maybe I take a little bit shadow. So I'm going to start with the measurement in accordance to the ISO standard. And I explain a little bit about the instrument. So you should see the camera. Now I'm going back to the software so that you can see the settings. Okay. I have the option to select different functions at the instrument. So we have here G7, we have the ISO check. ISO check is for checking the ISO standards. I am going to start with the ISO check right now. So I'm selecting this function here. And as you can see on the bottom right side, here are the settings. So you always can see if the settings are correct. D50, 2 degrees, no polarization filter, absolute white, and a measuring condition M0. So if you go to the setup for the ISO check, there you can, first of all, you can select if you want to scan a certain strip or if you want to make spot measurements. Then for sure you can select the ISO standard you want to work in accordance to. So we have the 2013 standard, 2007. We have the PSO 216, 212. We have IFRA, and we have also some other standards here. So let's go to the ISO 12647, 2013. You can choose between black backing and white backing because we have different reference values for that. And you can choose between the color and descriptions 1 to 8. So I have a premium coated paper here as a sample. Then I'm selecting this one. I'm going back to my measurement. And now let me switch to the camera so that you can see how I do the measurement. So I place the instrument in front of the first patch I would like to measure. We have the aperture here. So you can set it in front of the patch. You can align it and you make a scan. Just move the instrument across the color bar and you get the results on the screen within 2-3 seconds. Now I'm going back to the software so that you can see the results. And on the display, you can see all the values which are necessary to evaluate this print in accordance to the ISO standard. You see the delta L, A, and B for the paper white. So everything is within tolerance range. Then you can see on the left side the primary colors, CMYK, and all values are below delta E5, so all values are good. Then we have the TVI for 80%. You can see the TVIs are all in the range. And also for 40%, the TVI is still in the tolerance range, so that in total, the quality is good. And the midtone spread, that means the difference between the lowest and highest value in the 50% patch, is also in the range of less than 5%, so it's okay. If we want to have a closer look to the details, we have implemented a new function. This is a world premiere. You can see our news, which were planned for Drupa. So it's the first time I show this to the public. So we can see the dot gains for CMY to see how big are the differences and if they are in the green shaded tolerance range. So the next step would be we show the black, because the black we judge separately. Then we have the secondary, they have the primary colors. We can see the delta E's, the delta LAB. And finally, we are going back to the overview. So this is a very quick tool to analyze a print in a very short time. And you can see that the yellow, for example, is close to the tolerance limit, which is delta E5. So with a spot measurement, it is possible then to even judge how can I do better with that color. So if you place the instrument on a yellow patch and you take a measurement, spot measurement, a single measurement now the instrument is telling me, oh, I took the wrong patch, sorry. It's yellow here. Okay, we are delta E 4.8. So my current delta is close to the limit, but if I follow the recommendation to increase the density about 9% or 11 points, my delta E will come down to a delta E of 1.8. So the instrument will give the user a recommendation in which direction to move to get the best possible result. And these are also tools which help the user to, to be on the safe side, to reduce time and to manage all these reference and tolerance values within the instrument without taking care about the numbers. If you want to see the numbers, then it's very nice to have them on the display. So we have integrated that overview because it is quite difficult to collect all these values in the different standards. So we are presenting now the target values, the reference values, and also the tolerances that are set in the instrument for the primary colors, for the paper white, for the secondary colors, the TVIs, and the tolerances for the substrate and all the other colors. So this is the way how we are doing the ISO check. And as you can see, the measuring conditions is M1 because I'm using ISO 2013. So also the settings can be a reason for problems. And if I choose, let's say, the older standard, paper type 1 from the ISO 2007, and I'm going back, you will see that the instrument is taking care about the right settings automatically. This will avoid user errors and wrong values. So it's important that a modern instrument today is doing all these settings automatically. If we go from the ISO check to, let's do the media wedge, that is something you can check if your proof is a contract proof. Then we have all these FOCRA tables, also supporting also this type of reference values. And now I'm going back again to the camera so that you can see how I take the measurements on the FOCRA media wedge. It is a 3-line control element. I take a scan of the first line, scan from the second line. The instrument is going straight forward. It's quite easy and fast to measure. Okay. And I'm going back to the software so that you can see the results. So we do all the analysis in terms of the FOCRA reference values, printing substrate, primary colors, all patches, and also the CMY patches. So that is a quite easy and quick analysis of print and proof. And now I'm going to the next step. That means moving to G7, and for media wedge analysis, it is the same. So I can choose one of the standards. So for example, Cracon 2013. And we have, going back to the camera again, we have different control elements on our demo sheet. This is the Fogra media wedge. We have control elements for ISO. We have control elements for G7. And we also have the ID Alliance media wedge, control wedge, which is supported as well. So as soon as you select the reference values, the instrument will recognize which standard it is. And then we take the readings, again, 3 lines. So, and the last line. So the results are on the screen again. So just need to switch to the software again so that you can see it. Just 1 second. Okay. Now you should see the result on the display again. So compared to the Fogra media wedge, we are looking especially again for the CMY patches with a maximum delta C and the average delta C. And the rest is similar to the analysis of the media wedge. So if we are going now to...
Albin, sorry, but we don't see the application. If you're showing the application, it's not visible.
Yes, okay.
Sorry for interrupting you.
No, it's good because it's important that you see what I'm showing. It's okay now?
Yes, perfect. Thank you so much.
Thank you. Thank you. Okay, so this was the analysis of the ID Alliance control wedge, the 3-line control wedge. And here you see all the results in one view as well. So going now to the next step, which is the G7 analysis. And this is something we have developed together with the G7 experts of ID Alliance. So most of that, what we are showing now, is based on the input we got from the market, which was the same for sure for the ISO check as well. But this is having a very good results if you're working with the specialists very close together, because you deliver exactly what they asking for in a way that it is easy to understand. So the setup is nearly the same like in the ISO check. We have the settings here, D50, absolute wide M1. If we go to the G7 setup in the instrument, then again, we can select different control strips from different manufacturers, or we can make a single measurement mode. We can select the paper type, the CRPCs from 1 to 7, or we have the crack hole or the swap standard or the expanded gamut. So all standards are integrated in the instrument. You just have to select the one you want to work in accordance to. We can also turn on the auto reference. That means it's taking care about the substrate and is doing an automatic dynamical calculation for the results. And then you just, if you turn it off, then you can enter your neutral densities for all the patches, for all the gray patches. And for sure, you can also type in your tolerances. It's set to default. And as Neil has explained, the SCCA, that is a substrate corrected color aims, is available in the instrument as well. So all these difficult formulas are programmed inside the instrument, and the user has nothing to do than selecting the right standard, taking the measurement, and see the results. So going back to the camera, now I have a different step wedge. It is the G7 step wedge we have created. It includes all the patches that are necessary for the analysis. Again, I take a measurement. I scan across the bar. Once I finished, oh, I was a little bit fast today. So start again. Okay, I got the results. Going back to the software. So you can see the results about the G7 analysis. We are looking for the primary color, CMY. This is good. Delta E is 2.6. We have the black patch that is also okay. We have the trapping patches within tolerance range, also the paper white. And then we have the weighted delta L for the gray patches, CMY, the average and the maximum value. The same for the CMY weighted delta C, and the weighted delta L for the K patches, for the black patches. So except the average weighted delta C is out of range, the rest is okay. And again, here we can have a look into the details with the next display. And this is now the option where we can get a recommendation how to improve our results in terms of a neutral gray. So it's comparing the three densities CMY on a colorimetric way, is calculating the deviations, and then recommending please reduce magenta and yellow a little bit, and then you get better. It's the same like with the ISO check where we do density adjustments to get a better delta E. We do the same here for better weighted delta C. The next point would be we have a look on the delta E's for the primaries. So they are quite good. Delta E, everything is below 3. That's very good range. We can see also the delta L and the delta C. And then in the next view, we have a look about the gray balance patches. So also here we see the delta E, the weighted delta L, and the weighted delta C. And the next step, we have the gray patches, the weighted delta L, and also the delta E. So quite easy and fast to do an analysis, trapping patches and paper white, and get all the results in one view on the display. So this is how we are working with these options. Again, here we have the reference values, and you can double check if your values are correct, if you want to work in accordance to a certain standard. You also see the calculated values for CMY for the gray balance patches, as well as the K patches. If you turn on the auto ref, and if you're working with the SCCA, so that means your substrate is a little bit out of specs for the paper white. So the SCCA will do a correction and will calculate new aim values. And just to inform you that you are working with SCCA, it is specially marked in a color that you do not make any mistake. We take a reading. I get the values. And if I go to the references, I can see now that these values have changed. That means new reference values have been calculated to compensate the color of the paper. So all these options are integrated today in a modern instrument and can be selected by the user quite easily. So that was a quick overview about how to use a spectrophotometer and what to take care about before using it, because it's very important that the instrument is in a good condition and that it will provide correct values. So if you have any questions right now, then I'm happy to answer you. Maybe you can send them.